Hi everyone, this is a review of the material that we're going to have on our first quiz. We'll start with evaluating expressions. We're referring to algebraic expressions, and those are expressions that have variables or variable terms and could have a number also, a constant. So evaluating refers to the process of finding out the value of this expression when you are given the values for the variables. So this is a place where you would substitute these given values for the variables into the expression and then simplify your answer. So I'm going to substitute in 3 for x. I'm going to substitute in 4 for y, and I'm going to carry down the 6 because I'm not ready to do anything with it. My order of operations says take care of my multiplication first, which I have done. 2 times 3 is 6, 3 times 4 is 12, and I bring the 6 down again. 6 plus 12 is 18, plus the 6 is 24. So this is simplifying an expression once I have converted it to all numeric expressions. Notice how the shape works down into this sort of upside down triangle sort of shape down to the single term. This is what we would like your work to look like. We want you to show us the steps mathematically and algebraically that you are taking to solve or evaluate the expression. Here's a second expression, 3x plus y to the 4th power. So here's another place where I want to just make a suggestion to you that we might want to make it a habit to use parentheses when we're doing substitution. So when I substitute in the value of 2 for x, the operation between 3 and x here is multiplication. So putting the 2 in parentheses here reminds me to multiply. I'm raising negative 3 to the 4th power. Now, this is really important to have parentheses around that so we keep the negative with the number. An even power means I'm going to have a positive answer. And if I don't put the parentheses around that, I may make an error and treat it as a negative solution, and that would definitely give us the wrong answer. So negative 3 to the 4th power is actually positive 81. So I get the solution of 87 when I add my evaluated expressions together. The second topic we covered was distributive property. We've been working on that for several days now. The distributive property in an algebraic form would be written something like this. And this is often the way that we give general rules and properties in algebra. We actually write them up all with variables. So this expression says multiply the sum of b and c by the value of a. Distributive property says I can get the right solution for that by multiplying each term inside the parentheses by a. So a times the sum of b and c is equal to a times b plus a times c. This is the general rule. I know you're familiar with it. I do just want to remind you that the importance of this is when we have variables. When this is all numeric, you can use distributive property, but it's really not necessary if you know all the numbers. Where it really helps us is when there's a variable and we don't know all the numbers. If I have 4 times the sum of x plus 7, my rule says multiply each term inside the parentheses by the coefficient, which is the number on the outside of the parentheses. So my expression is 4x plus 28, simplified. You don't need to put the x in the parentheses here. I just did that so it would give you a form to look at, that I was treating them uniformly. Here are a few brief examples of distributive property. What I want to note to you is that you need to remember that the sign in front of the number stays with the number. And when there is no sign, visible sign in front of the number, we assume that it's a positive term. So here I have a negative 3 times x plus 1, the sum of x and 4. So negative 3x plus, this is negative 3 times positive 4. Okay, I have to take the negative with me. So this would simplify to plus negative 12, or, as you know, negative 3x minus 12. Minus 12 and plus a negative 12 mean the same thing. I'm going to erase that a little bit here so we can add the other two. Here we have 4 times y minus 3, so this would be 4y minus 4 times 5 is 20. I used the minus with the 5, treated it as a negative. 7 times 6 minus 3x. Here's something else I wanted you to see. It doesn't matter where the x term is inside the parentheses. You just still distribute the number to the two terms inside the parentheses. So 7 times 6 is 42. 7 times negative 3x is minus 21x. And I know we've spoken to you before about standard form would say move the variable to the front of the expression. The last thing here is don't be thrown off with the negative in front of the number here. I think we get what I mean here, right? The sign in front of the number stays with the number. So 9 times negative 4x is negative 36x, plus 9 times 2 is 18. Here's the last two examples I'd like to point out to you, and this is where we have distributive property with additional terms in the expression. Just as PEMDAS reminds us, you have to deal with the parentheses first, so you do the distributive property first. I'm going to just bring 6x down here for the ride. 2 times the 5x becomes 10x, and 2 times the negative 2 is minus 4. This is your distributive property, but you can't leave it this way because it's not completely simplified. You have to combine like terms. So like terms would be same variables or numbers, which is something that a lot of times students forget, that you can add the two numbers together or more numbers together. So let's put this together for its simplified form of 16x minus 4. The last example is where we have a fraction that we are distributing to each term in the parentheses. So this is 1/5 times 10x plus 1/5 times 15 minus the 9x. 1/5 of 10 is 2. I know some of you like to make this into a little fraction and do the multiplication. You are welcome to do that. So 2x plus 1/5 of 15 is 3 minus 9x, and to simplify that, the sign stays with the term, so 2x minus 9x is negative 7x plus 3. The last thing we want to talk about is how to translate verbal expressions to algebraic expressions. Here are 4 expressions that include the 4 operations. So I want you to pay attention looking for the math words for the operations, because those often give you a hint of where numbers should be. So I look for where the numbers are, the operations, and see what that tells me. So I have 9 plus, so I know I'm going to have an addition sign here. The quotient, all right, there is a math term for me. And it says the quotient of a number b and 16. So when I see a math word, I look for the 2 things that are following it are the 2 terms they want me to apply that operation to. So if I look for the and, I know that everything here in front of the and is going to go in the numerator of that quotient, and everything after the and is going to go in the denominator. It is very important, especially in division and in subtraction, that you get the terms in the right places. Okay, so I'm going to translate this into an expression. 9 plus the quotient of a number b and 16. The next problem says 14 plus the product of 12 and a number t. So I'm going to do the same thing. I have a number plus, there's where my plus is going to go, the product, and I'm going to look for the and, the product of 12 and a number t. So these are the 2 things that are getting multiplied, the 12 and the t. So if I were going to write this in an expression that was algebraic, I would write 14 plus 12t. And the next one is a number x squared plus 44 increased by t. So I have 3 operations here. X is squared, that's 1, plus 44, so that's another operation. And increased by, that was one of the words on our word wall. Increased by the t. So x squared plus 44 plus t. There's nothing else I can do here because these are all different separate terms, so there's no combining to be done. The last problem says 7 times the difference of 6 and a number k. So 7 times the difference. So I know that there's going to be a second operation following this, and I want to multiply the whole difference. So I'm actually going to use parentheses here. The difference is the math word. I'm looking for the and. Oop, I went a little too far. I'm looking for the and, which is right here. And this tells me the difference of 6 and my number k. So 6 and a number k minus k. Here's my expression. When we're asking you to translate verbal expressions, unless you're asked to simplify it, you wouldn't have to do the distributive property. But I want to just point out to you that you will often see distributive property phrased this way. 7 times and then a math word. When you see an operation like this, 7 times or times, and then you see a math word, it's very likely that what we want you to do is distributive property. Okay, that's it for the review. You should have some practice problems in order to get ready for the test. Good luck!